Hi everyone, my name is Steef. I'm one of the students at the course, the Max course at Kadenze with Stanford. And this is my final project for this course. And I'm doing a demo now. I'll do another video where I do a performance with this patch. So first of all, apologies for the reverb on my voice. This was the quickest way to actually get my voice recorded. So this patch has reverb built in, so it's just gonna take that reverb on my voice as well. So hopefully it's not too disturbing. And also this is probably gonna take a little while, this demo, because there's a few things that I probably should show. So let's dig in straight away. Also, I should probably say that this is my first Max experience. I don't really have any Max experience before this course. And also, I don't have any CS, computer science, or programming experience. So I really enjoyed this course, and I'm actually pretty happy with this result of this patch. And the idea was, there was actually no idea before I started, because before I started on the project, I was just sort of noodling around, and I had some, some thoughts and some experiments. And this is basically the coming together of some of these experiments that I had before I even thought about a final project. And so I literally just put them together and tried to make one holistic patch out of it. So it's might be a little bit Frankensteinish here and there in the way that it sounds, but I think the overall sort of piece is coming together pretty well, and there's a lot of controllability in there. So even if it's a little Frankensteinish, if you with a little bit of musicality, you can sort of make it work. Anyway, so let's dig in. So the three ideas are, so the one on the left here, so you see the input and analysis column. There's one idea in there, sort of in the analyze, motif, and store area down here. I hope you can see my mouse. And here where it has this abstraction saying analyze node motif. That's one of the ideas that I had. I was thinking, sometime in the future, maybe I want to try and build some sort of autonomous algorithm that I can play with, but that understands what I'm playing. So if I'm giving it sort of notes input, that it sort of has an understanding of what I'm playing, so that it can then bounce off of what I'm doing, and you can have a sort of back and forth going between my patch and myself. So what I needed for that is to analyze my sort of the incoming input. So I'm just opening it up here, and you see that it starts with an analyze node. So for every individual node, it will do an analysis. So it unpacks the incoming node, and it will get a MIDI node value and a velocity. And then the velocity, what it will do is it will use that to determine the duration of the node, because obviously the node on starts with a certain velocity, and then node off is going to be velocity 0. So by using that insight, you can basically record the duration of the node that's being held there. And by the way, this is essentially a monophonic entry. I didn't go as far as making this polyphonic, which probably isn't too complicated, but I just stuck with monophonic. So the idea is you play one note at a time, and then and that's how it works. So I use CPU clock because my assumption was, and I'm not sure if I'm right because I don't always get the best results, but my assumption was that CPU clock was going to be extremely well timed and perfectly timed and all that, but I'm not sure if that's always true, because I'm noticing that sometimes it doesn't seem to be extremely accurate, but luckily it's accurate enough to get musical results, so I kept it in like this. So that's the velocity, or specifically the duration there, and then here there's a subpatcher that I just literally have to look. I haven't seen this for like a month or so. That's bringing the MIDI note to the, oh that's right, so what I'm doing here is I'm actually breaking up the MIDI note into an octave and a sort of a chromatic degree within that octave. just so it's a little bit easier for me to understand as I look at it. I don't have to look at MIDI note values the whole time, but also it makes a little bit more sense if you want to try and map it to like a scale or something like that, which is what's going to happen later. Namely, right here, the patcher map node to scales. So here you see that I'm taking that I'm taking that node and map it to a chromatic scale. So I should note here that this is incomplete, as you can see here in the red letters. I have a bunch of chromatic scales here. This is the first step, which is mapping from the 0 to 11, which is the note value that came out of the that sort of left within the octave. So within the octave, you've got this note value, and I'm mapping that again just so I can look at it a little bit more easily. I'm mapping that to an actual note name, such as C and C sharp and so on and so forth. Then we get to the scales part, which is what I was explaining, which is I only have 9 scales in here. I should complete that with all the scales. Right now I just mapped out C major, D major, and so on and so forth, and then also E natural minor and C natural minor. So there's a whole bunch more scales that I actually want to input in here, and it's not even that hard, and everything else will work. I just used these 9 to continue to test it. The reason why I didn't complete it is because I'm actually not using the scales in the rest of my patch. This was already, as I said, this was thinking ahead of what I wanted to do. But in this particular patch, I'm actually not using scales. What I did want to use scales for in the future is if I understand where the notes are mapped to which scales they're mapped, then I can choose chords, I can choose, I can map the notes onto the scale and say, hey, this note is the 3rd note onto this particular scale, and then I can choose the right chord for it and so on and so forth. But I haven't gone as far as doing that. That wasn't part of this particular final project, but that's some of the things that I intend to do going forward. Okay, so that concludes sort of the node analysis here, I think. I'm not going to be talking about the specifics on how I'm packing and joining and all that. I think that probably speaks for itself. Okay, so then we get into the analyze node motif. So the idea here is, the reason why I chose analyze node motif is because I was thinking, okay, so on let's say a set of 4 notes, and actually you can see here on the left that the default is 4 notes per motif, and it can be any value. And that goes into this analyze node motif subpatch. So for, let's say, 4 notes, let's take 4 random notes. They have common scales, and that's the key thing that I'm doing here. Another thing that I'm doing in this subpatch is determining relative start times, because I had durations and I have start times. Actually, I didn't say that before. I also keep the start times from the CPU clock right here. So for the node itself, it doesn't really matter when it started. But it's handy because if I now go to analyze a motif, I can see the relative start times in between them. So here I've got a little patch that says, okay, if there's multiple nodes incoming, use that CPU clock per node to then determine what the actual node's relative start time is. And the first node that's incoming will always start on 0, so I'm just putting that back on a 0, and then everything else will get a relative start time in milliseconds, which then relates to that first node. So not to the so the 3rd node in the list is not related to the 2nd node, but it's still related to that first node, if that makes sense. Okay, so that's the relative nodes. Then we go to the scales. That's what I was talking about here. So now I'm going to score the scales because I'm getting a whole bunch of scales, and even though I have only 9 scales in this patch, it already gets to, often it becomes actually 9 scales, because if you play 8 notes, for instance, they often already relate to all the scales. So now what you need to do is actually rank the scales and then return the number of scales that you get the most. Yeah, that's it, essentially. So what's coming out of the third outlet is just literally the remainder of the node information. I'm just pushing that through. Out of the second outlet, the entire rank of scales is pushed, and then out of the first outlet, what I'm pushing out is just the top ranked. So just just the top ranked scales. I'm not sure if I'm going to go in all of this. It is not super complicated. Oh yeah, I also kept. I just found that again. I just kept an old effort to try and rank it. That went nowhere, and it took me probably, I don't know, a day or so just trying to rank my scales, and I was just in trouble. So then, after a while, I tried a different approach, and it's this one. It's also a little complicated looking, but I don't think I'm going to explain the whole thing. Actually, I'm thinking I'm pretty sure that there should be a super easy way to do this. Seems to me that in computer science, ranking should be a pretty straightforward thing, but it took me a long while. So anyway, what this is producing at the end is a stack rank with frequency. Oh yeah, I'm using the histogram feature right here. Histogram. So the histogram allows you to get a frequency per item in a list, and I wasn't able to just use the frequency, sorry, the scale, sorry, yeah, the scale names. So first I needed to map the scales to an ID. That's what's happening here. You don't see anything here because it happens live. And then I've got all those scale IDs. Then I'm going to rank them with the histogram. Then I have to map them back to the scales. It was a mess. I'm sure there's an easier way to do it. And again, this took me a long while. But in the end, I've got ranked scales. So I'm pretty confident that it doesn't matter if I have 9 scales or 20 or 30 or whatever. I think it will always produce the right top ranked scales for a given set of notes or for a given motif. Then after that, it's going to store the motif. And the reason why I did that was because initially I didn't even do that, but then I was thinking actually it would be fun if it would just play it back to me, some of those motifs. So then I needed to store them for a longer period than just for the duration of the analysis. So yeah, so I'm working with a call to store them temporarily. Again, this is empty now because I haven't started playing in the patch yet. And actually it will every time when you look at it, it will be empty because every time I clear it, so that when the new motif comes in, it won't be appended to a previous motif. So here's a temporary node list, and then here is going to be the dict, which I'm using to store multiple node lists. So let me actually just, yeah, you know what? Let me show you what that looks like. I'm just going to mute some things because I want to explain that later. So I'll play a motif, and then you can see that it's going to be stored here. So I'll play 4 notes. I've got my, I talked about my Q nexus already, I think. Maybe I didn't. I don't know. I need to look back what I discussed already. Okay, so I'm going to play 4 notes, and then, oh yeah, I didn't talk about the Q nexus yet. I know now. Okay, so I have to talk about the Q nexus still. Cool. So I'm playing on my Q nexus, which is a little keyboard that's connected to my computer. I'm going to play 4 notes, and then after I play 4 notes, it's going to be stored in a note list with a number. So here we go. Okay, there's the 4 notes. And here you can actually see on the bottom left, outside of the patch that's the patch that's in front. On the left, you can see the 4 notes are stored there. Then on a 0 index, I've stored the most frequently appearing scales, and then I've got the name note list 0, which is not exactly mapping the name here, but that's fine as long as I understand what I'm looking at. So here's number one, or yeah, well, it's in this case it's I'm starting to count at 0. But anyway, so if I now create another one, here's another 4 notes, and here's another 4 notes. Now I've got 3 note lists, and they're right here, so I can look them up, and then it will change down here. Will it? No, it will not. Okay, that's fine. I've got a lookup somewhere else, so I'll show you the lookup in a second. But what I did want to show you now is this is where it's being stored. Here is the latest dict. It has the latest node list number 2, which is the third one. And at the top here, it's actually storing the patch with the dispatcher new object piece. And you can see these just overlaying them all on top of each other. And this is one feature that I should build at some point, which is right now I don't have the ability to delete existing node lists other than doing it manually like this. If I wanted to do it now, of course I could delete them, but I want to do that programmatically. But the problem is I know that you can that you can give all these objects a name programmatically with the dispatcher and the scripting feature here. But the problem is if I do that, it actually appends that as an instruction to dict instead of as an instruction to script and dispatcher. And I had some issues with that, and I was too much trouble to figure that out, and the deleting wasn't that much of an issue. So, but anyway, that's sort of a thing that I want to build in here at some point. Okay, so yeah, this is where I'm storing multiple node lists. And with that, I think we're pretty much done. Yeah, for some reason my lookup isn't working. I don't know what went wrong there. It's interesting. Because what should happen is it should send the name through my lookup down here to my lookup node list, and then show this particular node list that I'm looking at here. But no big deal, because we can do the same here. Here you can see, here you can just skip through the node list. So here I can look up a node list. Okay, so with that, I think I covered the first experiment that I was doing, which was analyze node motifs. Yeah, my question for myself was, can I analyze a bunch of nodes, store them, and I could. So now I've got the nodes with the specific details per node. I've got the relative details in terms of how quickly they happened after each other. I have the relative information around which scales they are all part of, or at least which scale is appearing the most. And finally, I have a name. So that concludes the story around the analyze node motif. Now let me go back to the QNexus input. That wasn't necessarily a huge effort, but I needed an input, of course, for this patch. So this is not per se that one of the 3 experiments I was talking about. So this QNexus input, so QNexus, I'm not sure if you're aware, it's a portable keyboard that I own, and with, you know, piano-style keyboard. I'm using it here. I actually only started using that in the last, actually only today, I think, and I've been working on this for almost a month or so. So only today I started using the QNexus. I had it lying around somewhere, but I personally, when I'm on the go, I actually just really like just using the keyboard from the computer itself, from the laptop. So I have this little sub-patcher here that uses the keyboard from the laptop in my case. So here you can see, it's just a keyboard. Just if you look at the A, S, D, F, G, that's going to be C, D, E, F, G, and your QWERTY is going to be the black keys of a piano, and the A, S, D, F is going to be the white keys of a piano. So in case you don't have a QNexus and you don't have a MIDI keyboard, what you could do is just hook up this. So I'm copying that now. This piano key down up sub-patch or abstraction, and you could just paste it in here, and then it just works, as you can hear, with your keyboard. So anyway, so there you can, of course you don't have any velocity then, and that's why I changed it to Q-Nexus, because I wanted a little bit more musical expressiveness in here, and that's why I changed it to the Q-Nexus. Okay, so that concludes the left-hand side, other than to say that here you can decide how many notes you want in a motif. So if you do 8, and now I'm on my Q-Nexus again, now I have to play 8 notes before it stores the list, which I've done now, and here's my list. Okay, so the second experiment was around this here. I can unmute this now. Was around this interval delay pan synth. So now I've unmuted it, so now you can hear it again. What I wanted to do, I actually don't remember why. I think I was just going from the bottoms up. I think I just started with something and then sort of doodled and noodled, and then all of a sudden I ended up with this experiment. But what this does is it will play, and actually I'm going to mute this now. It will play what you're playing and then repeat it over time for as many voices as you have, which is four here, and over a delay that you can set here. And then in the end and it will, for each and every voice, it will jump to the next interval. So if you start at like a C, then with an interval of 7 it will go to a G in terms of semitones, and so on and so forth. Let me just make sure that I'm not lying. 1, 2, 3, 4, 5, 6, 7. Yes, that's a G. So anyway, and you can set any interval here. So you can make it, musical, like more typically musical is like a 7, which is like I actually don't know the English word for that. But it's, yeah, anyway. Or you can set it to something like 1, which is just a semitone, which is not going to sound as musical all the time. It depends a little bit on how you play with it, but it's super flexible, and you can get very interesting, if I may say so myself, very interesting musical effects, which I will try and demonstrate in the actual performance. But I'll give it away a little bit here. So if I play one tone, actually I'll play a little bit higher up, but you can hear it. If you're listening to this on headphones, then you can hear it pan from left to right, because that's every note is panned from left to right. Okay, so hopefully you got that. So I'll just show you some extreme values. So if you go to, actually that's one thing I wanted to do was presets, but I didn't. So here if I say 32 voices, and that's going to load a little longer because it's going to be a bit heavier. 32 voices, a delay of only 100 milliseconds, which is very short, and then an interval of 1 semitone, and you get a little, well, I'll show you what you get. You get a little effect like that. Or you can make it a little bit longer, let's say like this. Much longer. There you go. So you can get funny effects like that. So you can make it very effect-like. See, so, or you can go from all the way up. Okay, so you can get very effecty like this, but you can also get more sort of typically musical like this, which was the default setting, which is where you can sort of play a couple notes and then it will play it seven semitones higher and again, and that typically sounds, it's easier to make it sound well together. Okay, it's a bit weird to play it like this because I get a delay when I play it over that Soundflower thing, so that's going to be interesting when I do the performance later. Anyway, so that's the demo of that piece. Then I'll show you the innards. So we've got the same voices, delay, and the interval. By the way, the delay is a total delay, not the delay from one voice to the next. So it's from the first voice to the fourth. That's this one here. And that's how, yeah. So I'm using a polytilde down here, and instead of pushing all these things through the inlets, what I did was I just used sends because it worked pretty well, and I don't know if it's the best way to do it, but it worked pretty fine for me. Yeah, so we've got the total voices as a send, max delay as a send, and interval per voice. And okay, so let's see what that looks like inside the patch. So there's a MIDI note coming in, that's just coming through the normal inlet. No, that's not true, it's not coming through the inlet, that's, oh yeah, of course. The MIDI note is coming through this send over here from, in this case, the Q Nexus. MIDI note is sent here and then comes in here. And what I'm doing then, I'm delaying it. I use this delay anything with any length it sits in the pipe max help patcher. So in the help patcher for pipe, there's a very handy little delay anything with any length, and this is a little list that comes through, which then unpacks to the integers here. The list's not interesting, but the integers are the MIDI note and the velocity. And the velocity I am not meddling with that much, but the the MIDI note I'm meddling with because the interval here is calculated per voice. So if it's the first voice, of course, I don't want to add any interval, any changes to the note itself. But if it's the second voice or the third voice and so on and so forth, then of course I want this to scale to the right semitone, and in a musical way, not in a sort of extrapolated way that doesn't, that's not hitting an actual note. So that's what I did here. I did something similar, actually it's all very similar. I did something similar here for the delay of the voice. So here you can see delay anything with any length, and the first voice, which is the one that we're looking at, will get no delay because it needs to play as you're playing it as a user. But the second voice needs to come later, depending on the total delay which you get here, and the number of voices that you have, and which voice this actually is. And we're using this poly tilde here, that's being sent through to this inlet here. And then you just basically use all those things to determine what is the right delay time for this particular voice. I hope that all makes sense. As I'm going through this, I made this a little while ago, I can hardly follow myself, so I'm hoping that this is understandable for other people. Okay, then interval we talked about, then determine the pan position. Again, it's pretty similar, you do the same sort of expression and scaling where you take in the voice number from this poly, and you take the total voices from the total voices that we have in the that we can select at the top in the main patch. And then this here I borrowed. I thought I actually included a little thank you note in here. Oh, that's here. So yeah, you can see I used the panning max pad from Ian Mott and Karl-Heinz Essel. This is from 1997. They have a whole bunch of little abstractions that are very musical. So basically using math in musical ways, and here they use it to pan. So I'm using their panning abstraction, which I'm not going to explain, but I'm using their panning abstraction to then say, for the first voice I want to be on the left, for the last voice I want to be on the right. I believe what I did was I never really pan a voice entirely left, if I'm not mistaken. Yeah, actually you can see it here. So this voice is number 1, and it is, actually you can see it here. So this is the left gain and this is the right gain. So you can see obviously it's more on the left than it's on the right, but it's not fully left. So I forgot what my logic was here, but I didn't want it to sound way too panned. I wanted it to sound a little bit pleasing. And if it's literally, if you only have 2 voices and one sits in your left ear and the other sits in your right ear, that's not that nice. So I didn't want that. Okay, I think with that we talked about, everything for this particular idea. So yeah, that leads to that particular experiment, which I thought was a pretty cool result. Yeah, and you know, a lot of intervals are actually pleasing sounding. And actually, yeah, there's a lot of pleasing sounding intervals. So there's if you're gonna play with this, there's a lot of fun intervals you can play with, and a lot of effects that you can do. Oh yeah, what I also did, actually, okay, let me just conclude this section here. So that's basically this particular patch. And you know what? I'm actually going to reload it now because now I've been recording all these note lists, and I want to go to my next experiment, which, yeah, anyway, I want to explain my next part here, and I need the note lists for that, and I want them to sound. Actually, you know what? I'll do that in the performance. So here I'll just explain what's happening. Okay, so I've just concluded the interval delay pan synth. Oh yeah, by the way, I should say one more thing. There is actually a little synthesizer in here. Oh yeah, I didn't talk about that. The simple voice. So this is literally the barest bones synth that you can have. It's literally just a cycle tilde, and I didn't even have an ADSR. I just used the gain tilde, and what's coming in here is the velocity. So I just literally used the velocity to determine the gain. Yeah, so it's super simple. Luckily, it doesn't sound too simple in my perspective. Okay, and actually, while we're on the topic of voices, I probably should also explain this voice over here, which is the voice that's the reason I added this voice is because I wanted you to know when I'm playing versus when you just hear a bunch of repeats. Because as you know now, here's going to be repeats in the interval delay pan synth. But I'm also going to talk about something here where there's going to be more repeats. And I think as an audience, it's going to be a little bit confusing to understand what's actually happening, and I want it to be clear for the purposes of this demo and performance I'll do later. I don't think was really necessary for the patch itself, but anyways. So I have a voice here that sounds a little different from just a cycle tilde, and I mapped this a little bit after the what's that thing called, the micro brute and the mini brute, because they have, as you might know, I'm not sure if you're familiar with it. I don't have it myself. I don't think I've ever played on it, but there you can basically craft your own oscillator by mixing sine. I don't know if they have sine actually, but they definitely have a saw and a triangle, I believe, and a square, and then variants of that. And that's what this is doing here. So I wanted to experiment more with Gen. So I build it entirely in Gen. What you see on the left is basically just the UI. And on the right, what you can see is just a Gen. So I'm just literally adding up all the individual oscillators, and I have a few features such as frequency modulation, which is here, and pulse width for the square, and which is a train here. Okay. And the gain thing, the amp is the same thing. I'm just literally using a gain tilde, and just literally note on off is determining the. Actually, I can show you if I play a note. You see, it's just literally that. I don't have any sort of pleasing ADSRs on there or anything like that. Also, no filtering on there. But I'm happy enough with how it sounds for this particular thing. Okay, so that's that voice that I also needed to explain. And then, as you can see here, here's just a normal, what do you call that again? A button, a bang. And if I play on the keyboard, then you can see that I'm playing, and you can see it's a human that's playing. And now we get to the next experiment. I say 3 experiments, but I think it's way more than 3 already. But anyway, the next experiment is this section here, which is sort of part of the repetition of random motifs and so on and so forth. I'll switch it on now. and I'll switch this on again. So now if I play a motif, as I stop, it will start playing random motifs. So now we've got we've got 15 motifs stored here. I think this one was working better to look it up. So here you can see we've got 15 motifs, and it can just play through all of them. Actually 16, because we also have number 0. So if I play a new one like this one, it's not very musical, but anyway, then it will store it. And as I'm done, there's a trigger in there that says, when there's a long enough wait time after the human played, then please start replaying some of those existing note lists. So that's what it's doing now. It doesn't sound extremely musical because the input in the terms of the note list, they aren't too great. But I'm happy to say that I've been experimenting and playing with this, and if you play basically tunes that you like, then it will spit back at you some tunes that you like. That makes sense, I guess. Okay, so how it works, I'm just going to switch it off so we don't... Well, I'll let you enjoy it a little bit longer. And of course, it does adhere to, well, not of course actually, but it does adhere to some of these controls, not the number of voices, but it does adhere to the delay here, the max delay. If I make this shorter, it will play faster too. I'll explain in what sense it will play faster. When I change the interval here, the melody part here, the sort of the replaying of the melody won't be affected. But of course, oh, not of course, but I'll show you in a second. This will go back into the interval delay pan synth. And of course, that will then be affected by those semitones interval again. Okay, I think this explanation of this patch is going to take forever. So again, I apologize that you have to sit through this. I don't know if the demo was needed to be this detailed, but there you are. Okay, so I'll stop this, which it will do now. Oh, it looks like it's going to play one more time, but I think this is the last time. There you go. Okay, so let's look at what we're doing here. So yeah, here we just, if this is on, then it will replay. If it's not on, then it will stop replaying. Although for some reason it started replaying. I think I hit a button on my keyboard. Anyways, so, oh yeah, and I've got some user control here, which is I can speed up the way the melody is replayed here. So if it's just here on the ×1, which is the default, then it will just play back in the same way that the user played it in. But it can play slower if you do divided by 2 or divided by 4, and it can play faster if you do multiply by 2 or 4. And here, and I think you might have seen that already just now, it will show you a blue dot as it's playing notes here. So, okay, let's look inside. Okay, so bang when voice n+1 would end. So what that means is it's looking at both the input incoming here. Actually, I think it's looking at this one here. Yeah, let's just look inside. Yeah, so it's looking at the MIDI note velocity. And yeah, so it's looking at MIDI note velocity and then saying, okay, so when I am getting the last MIDI note velocity, use the max delay plus the voice delay from 1 to 2 to determine whether I should start sending a bang out, essentially. And if it sends a bang out, then it will start setting up the random note selection, and it will start playing a note list. That's the idea. So why max delay and why voice 1 to 2 delay? So the max delay is just so we can, does that make sense? Do I need to explain more? I guess I need to explain a little bit more. No, actually it makes sense. So if if the user plays something on the QNexus in this case, then the interval delay pan synth is going to continue to play for as long as the max delay. So you don't want too much overlap here from the entry here on the left, then the repeats over here, and then this on top of that there. So I wanted to avoid a whole bunch of overlaps. So I said, okay, max delay you need to wait. But I also added this here. You also need to wait, in addition to that, to one more sort of note. Oh, sorry, I should say one more voice delay time. And the reason for that is because it sounds a little bit more natural that way. If you would just do the delay time, it would immediately start playing after the last note has been played, pretty much, and repeated here. And that's just a little bit too fast. So I just use the time that it takes to go from the first note, which is played, to the second note repetition. And that sounded a lot more natural. Okay, then you get a bang. The bang then goes into random note list selection. So here you just look at what is the current dict, which is number 16, as we can see here. That then becomes our random, where we're going to choose one note from. The bang will then help us select a note, which will create a note list name, which will then be pushed to dict, and which will get a note from the receive note list. Do we need to say anything about the receive note list? I think I do. I'm a little confused where I have that myself. I'm guessing it's probably in the play note list then. Anyway, so here then it shows the current or the selected dict. And then here is probably the receive note list. I hope so. Otherwise, oh yeah, there it is. Cool. So the reason why, oh, I didn't put it here, did I? Getting a little confused now. I've been spending so much time on bug fixing that I just forget the basics of the patch. Okay, so here's the receive note list. Oh, no, of course, sorry. Yes, okay, I got it. So the story is the following. The note list, of course, the dict note list is that's stored already, so that's pretty easy. So the note list with the number that will give us the right note list from the in this case 16 or 17 note list that we have, and then it's pushing it to the receive note list. That's what's happening here. That says it right there. I should have known it. So it's being pushed to this receive note list over here. Here you see the note list. In this case it's 16 because sometimes it's a little buggy and then it has 16 instead of the maximum that I selected. But that's not a big deal. And then the bang will first push out the length. It will delete 2 from the length because there's always going to be a 0 which has the okay, too much detail. I think you can get it. So then you've got the length. The length will then go, okay, this, you can read that if you want to know what I did there. The length then goes into a counter, and then you're basically going to count all the way up to the length of the list. And basically what that does, it's going to play the entire list. And what I've done is I've just used all the details that's in the list, such as note duration, to determine first when descent to velocity, then when descent velocity 0, and then also use this piece over here, right? If you remember, the CPU clock or something, translation into milliseconds after the first note from the list, and you can use that then to calculate, to determine when the notes need to be played. So there's 2 different things. You've got note duration, that's basically handled within play current note, and you've got when to play the next note, which is handled here. And then also some gating and stuff to make sure that it doesn't endlessly keep repeating, but that it stops after it's done with the list and after, and if there's a if this doesn't say replay. Okay, I think with that we're pretty much done, and then we've got a little thing that says, you know, that just makes this is just for the UI. It doesn't actually change anything internally here. It just shows you what the random list is that has been chosen and that's being played right now. Not that it's easy to read or anything, but it's helpful. And that, I think, concludes the probably 4th experiment now. I don't know. So I have no idea how long this is taking already. I'm guessing I'm already babbling for half an hour, if not more. So again, I apologize, and let's go to the final thought here, which is when I started experiment with Jen, this little simple voice on the left here is I built that today. That was a later Jen experiment, but I was intrigued by the Jen piece of Max-MSP because apparently you can compile that more easily. I haven't really tried that yet, but what I would love to be able to do is actually at some point build some Max patches and MSP patches and Gen patches that I can compile in some shape or form, and then I don't know, use on a phone or use on another computer without the need for Max and so on and so forth. I already found out that they're not that elegant, but at least not for MSP and Max, but it works. And anyway, so I was intrigued by Gen. So wait, before I dig in, no, let's just dig in. So, oh yeah, what I wanted to do was the experiment here is around the rhythmic piece. What I wanted to do was build the rhythmic elements inside of Gen, if that makes any sense. So basically what you're seeing at the top here is UI. So we get a BPM. The BPM is derived here, is calculated from, I'm not going to explain this all, but it's calculated from basically the settings here. So a number of voices and the delay. Basically that maps to some sort of BPM. The BPM is spit out here. I'm saying I want my BPM always to be between 70 and 140. And that spits it out into this patcher with the BPM receive. And then the user can say, yes, I'm happy with that BPM, or I want it to be faster or slower. And then it's being used here in this rhythm. So, okay, you've got a BPM, and now you've got beats and bars, essentially. So beat units over here at the bottom. There's two voices in here, a left one and a right one. So for my left voice, there's a beat unit, and for my right voice there's a beat unit, and then there's a beats per bar for left and right. And actually, if I unmute this, I think they're playing. Yes, there they go. Look at them go. Can make it a little louder. So it's pretty mellow right now. Let's make them a little faster. So it's, you know, it's not pretty or anything, but it's a rhythm, and you can change the rhythm by changing the beats bars and beats per bar and beat units. So yeah, I'm not gonna explain it in full, but it works as described, I think. So you know, you could do some random, some sort of less usual meters, I think is the term, which we have here, like 7/2 and 5/2 is not extremely common. And you can do that, and then it starts doing that, and it starts playing. So anyway, so what I wanted to do, what my experiment was here, was to handle that not above the gen, but within the gen. So basically the information of the timing is being calculated here, because it needs to go back all the way to the samples instead of milliseconds or a BPM, and then it gets pushed into the actual gen patch itself. So yeah, so let's see, what do I want to explain here? I'm not going to explain everything, I think it's just too much work, and I'm getting tired of my own voice. So I'll just briefly touch on some things. So these voices are the same. This is my gen voice that sits inside another gen patch. So the big ideas, well, the main ideas in here is the envelope that's being triggered, and the triggering, that's the timing that's happening. So basically, via the inlets all the way to the top here, I'm getting the samples to determine my train length. And I'm not sure if you're familiar with the train. I wasn't before I started experimenting. Basically, train is a pulse over time, and so it sends out a pulse, and the pulse then determines envelope here built, I stole that idea of the envelope from an example within FM Bells. If you look it up, it's part of Max, if I'm not mistaken. So there's they've got a little envelope in there. I'm just using that envelope, and so they use history here to build a little envelope, and basically it's the smoothing here makes it just die down a little. Yeah, it makes it die down. So am I saying that correctly, or is the amp actually dying it down? I'm getting a little confused here now. I don't remember. What I do remember is my own idea was to use the train here to determine basically the train is going to trigger this delay loop here that then triggers, as a result, then becomes an envelope. That's basically the story in short. I'm sorry, it's a little bit complicated for me, so I'm struggling to explain it, as you notice. Here you can see a bunch of cycles which determine the actual sound. This is the bass frequency, if I'm not mistaken. Yeah, and you can't really change the bass frequency, but there's some frequency and ring modulation happening here, and that is being controlled from here. So let's go there. So here you can change some frequency and ring modulation. So it's not great. It wasn't really about the synthesis piece. It was more about the fact that I wanted to control my beats within the gen patch, and that worked, so I was happy with that. A couple more things to just quickly show is that here you can, in this little section, you can change the bass frequencies, so you can have lowered sounds or higher pitched, and it will choose a random, no, not random, but for the user probably appears to be random, but I think we're using a cycle to determine which to choose. But within the range that you select here, it will give you the note values back. So you can have a little bit more sort of like a hi-hatty or a belly type sound, if you want to call it that, or something that's a little bit more somewhat drummy, percussion-y like. Or you can just have it be completely, mixing it up. It's not fully random. It's not random at all. It's just based on a cycle, essentially. So, anyways, you can stop the rhythm here, and then it doesn't do it anymore. And then here, I don't remember why, but here, I think because I wanted to test all that train stuff. But here you can also trigger the envelope, and I build a little bouncing ball type thing here. As you can see, by the way, this is actually a sub-patcher, so if a B-patcher I should say, so if I open it, then here you can see the B-patcher. That has a bouncing ball effect in there, so I'm using a metro, which is basically sending the bangs, and then the bangs are being sped up with the cycle, and the cycle also affects the envelope length, so that if you have more bangs, that the result then is that you have shorter envelopes, otherwise they will overlap too much. And there you go. And then with the period and the comma, you can also, I'm doing it manually now, it's a period and a comma. I don't know why I built all this. As I said, this was just an experiment. I didn't know that I was going to use it in the final project here. And then here we've got envelope lengths that you can affect. The envelope lengths are also determined by this whole monstrosity here. Again, if you have more sort of beats per time unit, per period I should say, then I want to make sure that the envelopes are shorter so they don't overlap too much. Okay, and with that I think we're done. A couple things that you might want to look at is here I've got a few effects, but it's not really interesting. It's just BAP or beep, whatever it's called. I'm just using those just to make sure that it sounds okay. And finally, here I'm using a few global references and stuff that you can look at. All right, thank you very much.